We are going to begin by looking at a brief history of solar panels. The invention of the solar panel is credited to Edmund Becquerel, who discovered the photovoltaic effect. This is light's ability to generate electricity between metal electrodes. Photons knock electrons free from atoms, causing a flow of electricity. Willoughby Smith and Charles Fritts also made important contributions, and in 1954, Bell Labs created the first silicon solar cell. They worked through the photovoltaic effect as well as the establishment of an electric field. While the first solar panels were made with selenium, silicon dominates their composition today, as it is found to be around 5 times as efficient. The 3 main subtypes of silicon photovoltaic cells are monocrystalline, polycrystalline, and amorphous silicon. They differ on their efficiency and their flexibility. There are then added elements to help establish the electric field, including phosphorus and boron. The metal frame is usually aluminum, and casing and wiring completes the composition. Future possible compositions of solar panels involve using perovskite to enhance silicon solar cells. This has achieved the highest reported energy conversion efficiency of 28%.
Due to the abundance of silicon on Earth, it is used in many everyday objects. For example, silicon dioxide is a fundamental component of glass. Additionally, silicone is used for lubricants, polishing agents, and beauty products. Swedish chemist Jöns Jacob Berzelius was the first to isolate silicon. He accomplished this by heating potassium in a silica container and washing away the byproducts. However, humans have always used silicon, since it is in almost every naturally occurring rock or mineral, usually in the form of silicon dioxide.
The production of silicon involves heating sand with carbon to temperatures up to 2,200 Celsius. It can either have an electric grade by dissolving sand or HCl, or it can be a solar grade that undergoes chemical refinement through various gases.
There are several applications for silicon in regards to how it is used and applied. Silicon is a major component in manufacturing vast amounts of products such as cement, glass, and ceramics. The atomic structure of silicon makes the element an ideal semiconductor, which is why it's found in most semiconductor devices and transistors to amplify or reverse electrical currents. Silicon is also an important and basic component in the assemblement of computer chips. Commercial and economic impacts of silicon contributes to many job creations in the solar panel industry. This is an economically efficient resource to use because it's an environmentally friendly alternative to fossil fuels. Silicon is constantly being used as part of innovation in electronics, as it allows technology industries to grow with better processing techniques and replacing human personnel with advanced machines.
Some interesting facts about silicon is that it's the second most abundant element on Earth, making up 27.7% of the Earth's composition. This is second only to oxygen, which composes 46.6% of Earth. In addition, the oxide of silicon is the most common component of sand, which is composed of both divided rock and mineral particles. Finally, the chemical behavior of silicon is purely electropositive, meaning that during chemical reactions it loses electrons to form positive ions.